So this is one way to calculate the regression equation, what y equals mx plus b form for a regression model. What you need in order to do it is you need the average for your. Now, if you remember back, if you watch that other video that I made, the weight is explaining the number of medications that a patient is taking. So that's how this person set up this relationship to explore. So the weight is going to be our explanatory variable or our x variable, and the meds are going to be our y or our response variable. And I let the spreadsheet calculate the means for each of these, and then the standard deviations for each of these, and this is the correlation between the two. You know, you look at that correlation, we can tell that it's not really worth doing this because it's such a low relationship. There's not a lot of predictive value going on here, but this is the. I'm just going to try to show you how to use these formulas. Okay. Now, one way to remember this, of course, you don't have to because everything's open note. But slope is always the rise over the run, if you remember that from algebra, or you subtract the y's and put over the difference of the x's. So it's the same way with this formula. You put the standard deviation for the y's divided by the standard deviation of the x's times a correlation. So that's the thing you got to keep straight. If you reverse this, you're going to get an equation that tells you weight based on meds, and we want meds based on weight. So let's find the slope. So I'm going to take the 2.9324 all round to, divided by the standard deviation for the weights, which is 25.503. I'm going to multiply that by that correlation, that 0.0. Let me get rid of that extra x I just wrote. And multiply that by 0.0415. So on my calculator, I'm seeing this is about equal to 0.00. I don't know. I'm going to call it 3 decimal places, so 5 is 0.04. 0.00477 is what I'm getting. So I rounded. 3 decimal places is usually plenty. And then to find the y-intercept, we're going to take the average. It says take the average of the y's, so the y bar. Then subtract this product of the slope we just calculated times the average of the x's. So we've got to remember to follow order of operations with this. So I'm going to do, let's see, y bar is 2. Nope, wrong one. 4.433 is probably close enough, minus the 0.005 times the average of the y's, which was 80.161. And if you're using a graphing calculator, you could type that in just the way it is. It'll give it to you. One thing you got to remember, if you're not, is you got to multiply these two numbers first, then subtract that product from the 4.43. And my calculator is telling me that that is 4.029. Okay, so there's the y-intercept. Here's the slope. The last step is to actually write a regression equation. We can use y and x. I always like to write this. So we're going to do number of meds, which is our y variable, equals 0.005 times the weight of the patient plus 4.029. Okay, you could also write this as the statistical form where you put the y-intercept first, but this is perfectly fine. So that's the process, and this is how I'm going to ask you a question like this in the next exam. Okay, so this is the end of chapter 15. Has in the Mora book has 3 or 4 exercises just like this. Okay, hope that helps.